Good afternoon to all. Did you learn the previous day portion? Only some of them are sent your answer to me. Remaining few of them are not submitted the answer. And also please, you should be write on assignment note. Okay, don't use paper for writing the answer. Okay, today our portion learning objectives. Again the unit 1 learning objectives. To learn about empirical formula and molecular formula. What's our today learning objectives? To learn about empirical formula and molecular formula. In an elementary analysis of a compound gives the mass percentage of an atom present in a compound. An empirical analysis of a compound gives the mass percentage, having some percentage of mass of an atom present in a compound. One compound having some of the atoms have some mass percentage. Using the mass percentage, we can determine the empirical formula of the compound. Okay? Using that mass percentage, we can determine the empirical formula of the compound. Here, empirical formula of a compound is the formula written with the simplest ratio of the number of different atoms present in one molecule of the compound. It is a simplest ratio, having some ratio. Carbon this much, how much? This much. Hydrogen. Carbon may be 2, hydrogen may be 1. Like that, it's a simple ratio. The simple ratio of number of the different atoms present in one molecule of the compound. But molecular formula of the compound, that is have formula written in the actual number of different atoms present in one molecule. Molecular formula of a compound is the formula written with the actual number of different atoms present in one molecule of the compound. One molecule. For example, let us here consider the acetic acid. The acetic acid formula is CH3COOH. This is the formula for acetic acid. This is the molecular formula for acetic acid. This is the formula for acetic acid. Here, the molecular formula, how can we write the molecular formula? Already I told you about the acetic acid formula. CH3COOH. Clear? CH3COOH. Here, how much C is there? Shall we write on the board? Okay. The formula for acetic acid formula CH3COOH. This is the formula for acetic acid. Here how much carbon is there? 1 carbon, 2 carbon. So we can write as C2. How much hydrogen is there? 3, H3 and 1. So H4. And how much oxygen is there? 2 oxygen, O2. This is the molecular formula of acetic acid. That is, carbon, count the carbon, 2 carbon is there. So C2, hydrogen how much? 3 plus 1, 4, and oxygen 2. This is the formula for, molecular formula for acetic acid. Here, you should be write the ratio. What's the ratio here? We can be taken as ratio is equal to 1. Ratio is equal to 1. 1 is to 2 is to 1. Clear? What's the ratio? 1 is to 2 is to 1. And the empirical formula can be written as, here empirical formula can be written as 1 is for carbon, that is C, 2 for hydrogen, H2, and oxygen 1. So this is the empirical formula and this is the molecular formula. Can we differentiate the empirical formula and molecular formula? This is empirical formula can be written as per the ratio. We are giving the ratio. By ratio we are taking an empirical formula. Here our number of elements, and based on number of elements, that is the molecular formula. Clear? Have it out? No. Okay, the next learning objectives to learn about the determination of empirical formula from the elemental analysis data. To learn about determination of empirical formula from the elemental analysis data. Here, first of all, some data. What are the data? They have 4 steps. The first step is that compound is expressed in percentage can be consider the total mass of the compound as 100 gram. We are taking for each and every formula the total mass of the compound is taken in 100 gram and the percentage value of individual element of mass in gram. Okay, first take the percentage can be considered the total mass of the compound. The percentage can be considered the total mass of the compound as 100 gram. How much gram? 100 gram. The percentage can be considered total mass of the compound as 100 gram. The percentage value of the individual element of mass is in gram. Mass in gram. That is step 1. What is step 1? What is step 1? The composition is expressed in percentage can be considered the total mass of the compound as 100 gram. Okay, and the percentage value of individual element as mass in grams. Mass in gram and percentage is total mass of the compound is 100 gram. Okay, this is step 1. What is about the step 2? Divide the mass of each element by its atomic number. Divide the mass of each element. Divide the mass of each element by its atomic number. What is about the step 2? Divide the mass of each element by its atomic number. Next one, third step. Divide the value of relative number of moles obtained in step 2 by the smallest number of them to get the symbol ratio. What's the step 3? Divide the value of relative number of moles obtained in the step 2 by the smallest number of them to get the symbol ratio. This is the third step. Then fourth step. In the case the simplest ratio obtained in the step 3 are not whole number, then they may be converted into whole number by multiplying a suitable smallest number. Okay, once again, in the case of simplest ratio obtained in the step 3 are not in whole number, then they may be considered into whole number by multiplying a suitable smallest number. Okay, this is only the theoretical. This is not an important. But what is important here? We are giving one question. How will you write the empirical formula of the compound? How will you write the empirical formula? There are some three problem question having. First of all, please watch carefully how I am going to write. Please all of you take your note now. Take your note and open your textbook, page number 11. Okay. Okay. Now all of you please take page number 11 and take the note with the pen. We can do some example. A few more examples. It is a very, very important question. Last year board exam question. So all of you do this problem. Example number 1, page number 11, first volume book. An acid found in terminal analysis show the following percentage composition. What are the following percentage composition? 32% carbon. Carbon has how many percentage? 32. 4% hydrogen and 64% oxygen. Find the empirical formula of the compound. That's the question. In this question, having 3 elements. Which are the 3 elements? Carbon, hydrogen and oxygen. For this, you should find the empirical formula of the compound. Okay? Empirical formula of the compound. First of all, you should make one tabular column. Tabular column you are taking. Here you are taking 4 columns and 6 rows. Okay? Clear? First we should be write the element. Which are the element having? Element. First column you should be write element. As per this acid having, which are the element having this acid? Carbon, hydrogen, oxygen. Here. So first you write carbon. What is the symbol of carbon? C. Then second element, hydrogen. Third element, oxygen. Next you write the percentage. Okay? Percentage. How much percentage carbon having? 32. How much percentage hydrogen having? 4. How much percentage oxygen having? 64. Next one is molar mass. Otherwise write atomic mass. The atomic number of carbon is 6. The first element, the atomic number of carbon is 6. What is the atomic mass of carbon? That is 12. Okay? If you have any doubt, means you should be open the 10th standard book. They are having about the atomic mass and atomic number. What about the hydrogen atomic mass? 1. What about the atomic mass of oxygen? 16. Atomic number is 8. Atomic mass is 16. Clear? This 3 over. What's the fourth one? Here, relative number of moles. Relative number of moles. Okay? Further, how will you find out this one? First you write what is the percentage of carbon here? 32. 32 divided by what is the atomic mass of carbon? 12. Relative number of moles means percentage divided by atomic mass. What's the formula? Percentage divided by atomic mass. Okay. Next. 32 divided by 12. What is the answer? Approximately equal to 2.66. 2.66. Clear? Then what about the hydrogen? Percentage divided by atomic mass. Percentage divided by percentage is 4. 4 divided by atomic mass. That is 1. 4 divided by 1. What's the answer? 4. Okay? Next about oxygen. Percentage divided by atomic mass. That is 64 divided by 60. Okay? That is also 16 into 4 is equal to 64. We can write as answer 4. The next one is simple ratio. How will you find out the simplest ratio? That is, here, which one is the least value? For example, 2.66 having here, second one 4, second one also 4. So, for the first one, this value divided by which one is the least value? That is 2.66 divided by the least value also 2.66 is equal to 1. Okay? Next about 4 divided by the least value. 4 divided by the least value is 2.66. Clear? When you are dividing, we get approximately equal to 1.5. This answer. And also here also 4 divided by the least value is 2.66. That is also 1.5. Now, simple ratio in whole numbers. Here, as per the the step 4, already I told you about the step 4. The simple ratio obtained in the step 3 are not in whole number. Here are not in whole number. Then they may be converted into whole number by multiplying a suitable smallest number. We are multiplying by a suitable smallest number. If you are multiplying with 1 means that is the same value you get. Okay, so multiply by 2. 1.5 divided by 2 means we get 3 answers. Okay, that same 2 you write here. Okay, simplest whole number. Okay, then here also you should be multiplied by 2. That is answer 3. Here, this is answer, and also you should be right. What is the empirical formula of this compound? You should be right. What is the empirical formula? Now, please tell me, carbon, how much simple ratio we got? 2. So, C2, hydrogen, how much we got? Hydrogen, 3. H3, oxygen, 3. O3. This is the answer. Can you write? Have it out? No. Suppose if you have any doubt means we can do the next problem that is same like that. Okay? Then I have the board. Okay. Okay, the next question. An organic compound present in vinegar. What's the question? An organic compound, example 2, an organic compound present in vinegar has 40% carbon, 6.6% hydrogen and 53.4% oxygen. What's the question? An organic compound present in vinegar has 40% carbon. How much percentage carbon? 40%. 6.6% hydrogen and 53.4% oxygen. Find the empirical formula of the compound. Find the empirical formula of the compound. That's the question. Okay? And you should be take table column. Okay? The table column. There are 4 rows and 6 columns. Okay? One, 2, 3, 4, 5, 6. Okay? So, question. And this organic compounds, which are the element present there? First we check the element. Which are the element? Element, carbon one element, hydrogen one element, and oxygen. Element. Carbon. What is the symbol of carbon? C. Symbol of hydrogen? H. Oxygen? O. Have it out? No doubt. Okay. Then, what is the percentage? Percentage. Next about the percentage. What is the percentage of carbon? Percentage of carbon how much? 40%. Clear? 40. What is the percentage of hydrogen? 6.6% of hydrogen. Clear? Then about oxygen, 53.4% of oxygen. Next about the atomic mass. Atomic mass. Atomic number of carbon is 6. What is atomic mass? 12. 12 is the atomic mass of carbon. What about the atomic mass of hydrogen? 1. Atomic mass of oxygen, 16. Clear? Have it out? No order. Next about here relative number of moles. Relative number of moles. Relative number of moles. How will you find out the relative number of moles? Percentage divided by atomic mass. Percentage divided by atomic mass. Okay. Here percentage is about 40%. So 40 divided by 12. Please multiply, divide and say 40 divided by 12. So approximately equal to 3.3. Can you write? Next about hydrogen. Percentage, what is the percentage of hydrogen? 6.6. 6.6 divided by 1. Can you say what's the answer? Same answer, 6.6. Next about percentage of oxygen, how much? 53.4 divided by atomic mass 60. Please multiply and say, divide and say, what's the answer? 53.4 divided by 60. That is also approximately 3.3. Clear? That is simplest ratio. How will you find out the simplest ratio? The given value divided by the least value. Which one is the least value? This is the given value. 3.3 is the given value. What's the least value? The same 3.3. 3.3 is equal to 1. Next about, what's the next one? Is 6.6. Divided by the least value, 3.3. It's equal to 2. Next about 3.3 divided by least value 3.3. Okay? Simplest ratio in whole numbers. In whole number. Okay? What's the answer? Here having all whole number, right? So the same 1. Here 2. Same 2. Here 1. So the empirical formula of this organic compound, you should be right. Which are the element present? Carbon. Carbon how much? Carbon 1. So carbon 1. Next one. Hydrogen 2. Hydrogen 2. H2. Next one oxygen 1. Oxygen. So the empirical formula of this compound is CH2O. The empirical formula of this compound is CH2O. Can you write? Have it down? The simple method: the element, percentage, atomic mass, relative number of moles, simplest ratio in whole number. Then the element right, percentage right, atomic mass, relative number of moles, and simplest ratio. So very easy. Okay. Okay. The next one is question having that we should be do the assignment. It's a simple question. Do the assignment. Next about molecular formula. Here the molecular formula of the compound is the whole number multiple of the empirical formula. Okay. Molecular formula of a compound is the whole number multiple of the empirical formula. The whole number can be calculated from the molar mass of the compound using one following expression. What is the following expression means? Whole number, that's the symbol is N. N is equal to molar mass of the compound divided by calculated empirical formula mass. Whole number is N is equal to molar mass of the compound divided by calculated empirical formula mass. Listen all of you. As per this formula, we are doing another one problem. Okay. Next about how will you calculate molecular formula from empirical formula? Molecular formula from empirical formula. Okay. First of all, make it a table column. First we write compound. Next one, empirical formula. Compound, empirical formula. Next one, molar mass. Next one, empirical formula. Empirical formula mass, whole number. Next one, molecular formula. Here compound, first one is acetic acid. Acetic acid. Acetic acid empirical formula already learned that one. What's the formula? CH2O. The previous we learned acetic acid empirical formula CH2O. Next about the empirical formula. Okay. Next molar mass of acetic acid, that is 60. How will you find out the molar mass? Molar mass of acetic acid. How will you find out the molar mass of acetic acid? What is the formula for acetic acid? CH3COOH, acetic acid. Okay. Here, number of carbon. How much number of carbon there? 2. So, 2 into 1 carbon having molar atomic mass is 12. 2 means 12. That is 24. Plus, next about carbon. Okay, hydrogen. There are 4 hydrogen. So, 4 into 1 plus oxygen. 1 oxygen atomic mass is equal to 16. 16 into 2. Okay, this is 2 into 16. How much? 24. 2 into 12 is equal to 24. 24 plus 4, 28. 28 plus 32. That is 60. Clear? So the molar mass of acetic acid is 60. Clear? Next one, empirical formula mass. Empirical formula, that also we will have that. How will you find out the empirical formula? Empirical formula mass. 1 carbon is 12. Clear? 12 plus hydrogen 2. 12 plus hydrogen 2 plus oxygen 16. How much? 14. 14 plus 6, 20. 20 plus 10, 30. Clear? As per this atomic mass. Okay? Then whole number, this 60 divided by 30. 60 divided by 30. 60 divided by 30. What's the answer? 2. Okay. Next about the molecular. What do you know about the molecular formula? CH2O. Here CH2O, the empirical formula, CH2O multiplied by this 2, multiplied by this 2. So 2 into C is equal to C2, hydrogen, 2 2s are 4, H4, oxygen, O2. This is the molecular formula for acetic acid. Molecular formula for acetic acid. Clear? Can you write? Can you write? Okay. Next about hydrogen peroxide. Hydrogen peroxide. Okay. Then empirical formula for hydrogen peroxide, that is H2O2 and divided by 2. So what is the answer? OH. OH is the answer. Am I right? Clear? So empirical formula for acetic acid, empirical formula for hydrogen peroxide is OH. Clear? Next one, molar mass of hydrogen peroxide. What is the molar mass of hydrogen peroxide? That is H2O2. The molar mass 2 into 1. 2 into 1 plus oxygen 16. 16 into 2 is equal to how much? 16 into 2 is equal to 32. 32 plus 2 is equal to 34. Clear? 34 is the molar mass of OH. 34. Okay? Next about the empirical formula mass for hydrogen peroxide. Empirical formula mass, that is here oxygen having 16, atomic mass is 16. 16, hydrogen having 1 plus 1 is equal to 17. Next about whole numbers. Whole number, how will you find out? 34 divided by 17. 34 divided by 17. 34 divided by 17 is equal to 2. So what is the formula, molecular formula for hydrogen peroxide? OH into 2. Clear? OH into 2 is equal to, how much hydrogen is there? 2 hydrogen. So H2, how much oxygen is there? O2. This is the formula for hydrogen peroxide. Clear? Next about lactic acid. The third one is, next one is the lactic acid. This molecular formula we can be calculated later only. First of all, they will give the empirical formula. The empirical formula for lactic acid is equal to CH2O. CH2O. Clear? Then the lactic acid empirical formula. How will you find out the lactic acid empirical formula is over? CH2O. Then about the molar mass of lactic acid. What is the molar mass of lactic acid? Here we can find out lactic acid CH2O. C carbon having CH3, CHOH, COOH. This is the lactic acid formula. Actually, this is the lactic acid formula. First, you should be find out number of carbon. How much? 1, 2, 3. 3 carbon having, right? 1, 2, 3. 3 carbon having. So 3 into carbon atomic mass is equal to 12 plus 3 into 12 plus hydrogen. How much having? 3, 4, 5, 6. So 6 into 1 plus, next one oxygen. How much you having? 1, 2, 3. So 3 into oxygen having 16 atomic mass is equal to what's the answer? 3 into 12. What's the answer? 36. Is it? 36 plus 6 plus this one is 16 into 3. What's the answer? What's the answer? 48. Okay. So make it here 48. So we get that 6 plus 40 is equal to 90. Okay. So the molar mass of lactic acid is equal to 90. Then empirical formula mass, that is here, how much carbon is there? 1 carbon. So 12 plus 200 is there, 2 plus oxygen 16. Okay, so what's the answer here? 12 plus 2, 40 plus 16 is equal to 30, right? Okay. Next, whole number n is equal to, how can we calculate? Molar mass divided by whole number. Molar mass divided by empirical formula mass. It is 90 divided by 30. So the answer is 3. Clear? Next one. How will you find out the molecular formula? Here we get 3. So this value into 3. This value into 3. CH2O into 3. So what's the answer? Carbon 3 into C is equal to carbon 3. Hydrogen 2 into 6. 2 into 3 is equal to 6. Hydrogen 6. And oxygen 3. So the molecular formula for lactic acid is equal to C3H6O3. C3H6O3. This is the lactic acid. Okay. Next about tartaric acid. Here, tartaric acid. Tartaric acid. The empirical formula for tartaric acid is C2H3O3. This is the empirical formula for tartaric acid, C2H3O3. This is the empirical formula for tartaric acid. What is the molar mass of tartaric acid? Okay. Here, molar mass of tartaric acid. That also you should find out. What is the molar mass? Actually, tartaric acid is having carbon C4, hydrogen 6 and oxygen 6. Can you find out this answer? Carbon. How much carbon is there? 12. 4 carbon. 1 carbon is 12. So 4 into 12 plus hydrogen 6 into 1 plus oxygen 6 into 16. Clear? Then we can multiply and we get answer approximately equal to, I think, that 150. 150 is the molar mass of tartaric acid. Okay. Next about empirical formula for tartaric acid. Empirical formula. Here, how will you find out how much carbon is there? 2 carbon. So 24 plus hydrogen 3 plus oxygen 16 into 3. Approximately equal to 75. Clear? Then, how will you find out the whole number? That is molar mass divided by empirical formula. 150 divided by 75 equal to 2. We get answer 2. So, multiply by 2. That is C2, here formula C2H3O3 into 2. So what's the answer? 2 to 2 is equal to 4. So carbon 4, hydrogen 3 2s are 6, H6, oxygen 3 2s are 6, oxygen 6. So the formula is C4H6O6. The last one is benzene. Benzene, the molecular formula of benzene is C6H6. C6H6. Okay. The structure of benzene is, this is structure of benzene. Okay. Otherwise, alternative double bond. Structure of benzene. Okay. So each position having CH, 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 CH. So how much carbon is there? 1, 2, 3, 4, 5, 6. 6 carbon. How much hydrogen is there? 6 hydrogen. 1, 2, 3, 4, 5, 6. 6 hydrogen. Here, benzene. Empirical formula for benzene is equal to the simple ratio. As per the simple ratio, carbon is taken as carbon 1 and hydrogen also 1. Okay, CH. This is the empirical formula for benzene, and also the molar mass of this benzene. Okay, carbon having 12. 12 into 6 is equal to 72 plus 6 into 1 is equal to 6 is equal to 78. 78 for molar mass of benzene is equal to 78. The empirical formula for here benzene, empirical formula for CH is equal to, that is a 12 plus 1, carbon having 12 and hydrogen having 1 is equal to 13. 13. So the whole number, how will you find out the whole number? 78 divided by 13. 78 divided by 13. 78 divided by 30. 78 divided by 13 is equal to, we get 6. The answer. So multiplied by 6. This CH into multiplied by 6. CH multiplied by 6 is equal to, how much carbon is there? Carbon C6. How much hydrogen is there? H6. Clear. So the molecular formula of benzene is C6H6. Okay. For the assignment, for the tomorrow assignment, our class is over. Tomorrow assignment, page number 11, example 1 and 2. Listen, all of you, if you have any doubt, don't worry about that doubt. We will discuss later. Anyhow, you try it, how to solve this problem. Otherwise, you call me, I will help you. And also, do the page number 11, evaluate yourself, 5th one. That also, if you have any doubt, means you shall do it, otherwise call me. Okay? Thank you all for time.